Natural gas is a versatile energy source that can be used in a variety of applications. Here are some of the most common uses of natural gas. 1. Natural gas is commonly used as a fuel source for home and commercial heating systems, including furnaces, boilers, and water heaters. 2. Natural gas can be used as a fuel source for vehicles, including cars, trucks, and buses. This is known as compressed natural gas, CNG, and is a cleaner burning alternative to gasoline or diesel. 3. Natural gas can also be used to generate electricity and is used as a raw material in the chemical industry to produce a variety of products, such as fertilizers. Natural gas is a cleaner burning fuel than other fossil fuels, such as coal and oil. Natural gas can be captured from the Earth's crust by drilling wells into underground reservoirs that contain pockets of natural gas. The natural gas is then brought to the surface where it is collected and transported to processing facilities. Here are the main steps in the upstream process of natural gas processing. 1. Exploration. The first step in the upstream process is to identify potential natural gas reservoirs through geological surveys and exploratory drilling. This allows companies to gain insight into the size, shape, and location of potential gas reservoirs, as well as the potential risks associated with drilling in that area. It also allows them to determine the best drilling methods to maximize the recovery of the natural gas. 2. Drilling. Once a reservoir has been identified and assessed, the next step is to drill a well. Drilling involves using a drill bit to bore a hole into the ground, usually to a depth of several thousand meters. The well is lined with steel or cement casing to prevent it from collapsing. The casing also helps to ensure that the well is watertight, protecting the aquifers or other natural resources it passes through. 3. Completion. Once the well has been drilled, it is completed by installing equipment to facilitate the production of natural gas. This may involve the installation of a wellhead, which controls the flow of gas from the well, as well as tubing and other equipment to allow the gas to be extracted from the wellbore. The wellhead must be installed properly to ensure the safe, reliable, and efficient extraction of gas. 4. Production and surface facility processing. Once the well is completed, natural gas can begin to flow from the reservoir to the surface. This may involve the use of pumps, compressors, or other equipment to transport the gas through pipelines to processing facilities. The processing facilities then prepare the gas for commercial use by removing impurities such as water, oil, carbon dioxide, hydrogen sulfide, and other hydrocarbons. Once the gas is ready, it can be stored or transported to end users such as residential homes, businesses, and power plants. 5. Transport. Once the natural gas has been processed, it is transported through pipelines to distribution centers and storage facilities, where it can be distributed to customers for use as a fuel source. While the composition of natural gas can vary depending on its source and processing, here is a typical composition of natural gas. 1. Methane is the primary component of natural gas and typically makes up between 70 to 90% of its volume. 2. Ethane is the second most abundant component of natural gas, typically making up between 5 to 15% of its volume. 3. Propane is a heavier hydrocarbon and typically makes up between 1 to 10% of natural gas volume. 4. Butane is another heavier hydrocarbon and typically makes up less than 0.5% of natural gas volume. 5. Carbon dioxide, water, nitrogen, hydrogen sulfide can be present in natural gas as an impurity. Here are some common specifications for natural gas. 1. Water content. Natural gas specification for water content in between 4 until 7 pound per million standard cubic feet. 2. Carbon dioxide content. Natural gas specification for carbon dioxide content in between 1 until 3% of natural gas. 3. Hydrogen sulfide content. Natural gas specification for hydrogen sulfide in between 10 until 50 part per million of natural gases. 4. Heating value. The heating value of natural gas is the amount of heat that is produced when it is burned. It is typically measured in British thermal units, BTUs, per cubic foot or per unit volume. The heating value of natural gas can range from 900 to 1100 BTUs per cubic foot. The heating value of natural gas depends on its composition, particularly the percentage of methane, which has the highest heating value of all the components in natural gas. 5. Hydrocarbon dew point. Natural gas specification for hydrogen dew point at 15 degrees Fahrenheit at 800 sig. 6. Delivery operating condition for pipeline. Delivery pressure minimum 700 sig and delivery temperature maximum at 120 degrees Fahrenheit. Thanks for watching the Observant Engineer channel. Be sure to like and subscribe for more content. Tell your friends about this video and don't forget to hit that like button. Don't forget to leave your comments and questions down below. That's all for today. See you next time.